Imagine for a moment having access to, well, every single piece of information ever created.
Yeah.
I mean, everything.
It's mind-boggling, isn't it?
Totally. Every scientific discovery, every human thought, every data point, from the dawn of time until right now, an unimaginable volume.
An infinite library, yeah.
Exactly. Now here's the real kicker, the immense challenge. How would any intelligence, whether it's artificial or frankly anything else, even begin to make coherent sense of all that?
How do you not just get completely overwhelmed?
How would it possibly process, organize, and crucially, use such a vast ocean of knowledge without just freezing up, being paralyzed by its own sheer size? How does knowing everything actually translate into doing anything useful or, truly understanding anything in our dynamic, constantly changing world?
That's the central question, isn't it? Moving from just having data to having usable intelligence.
Okay, let's unpack this. Today we're diving deep into this really fascinating document. It's titled Cognition, Site-Sensitive, Vielschichtige Intelligenz in KI and Kern. And this research explores some really cutting-edge concepts right at the heart of how advanced intelligence might operate, not just in us, in the human brain, but critically in the advanced AI systems of the future, the ones that might actually get close to this idea of knowing everything.
Yeah, the potential is staggering.
So our deep dive today focuses on this pivotal intersection of two incredibly powerful ideas. First, meta-temporal coordination.
MTC.
And
yes.
second, layered cognition processing. And these aren't just like academic buzzwords. They seem to represent a new blueprint, maybe, for creating truly robust and, importantly, adaptive intelligence.
What's really fascinating here, I think, is that this isn't just, theoretical speculation coming out of one single field.
Right.
The insights in this document, they actually come from this rich blend of cutting-edge brain research and advanced AI development. It shows this amazing synergy between understanding biological intelligence and engineering artificial cognition.
So learning from nature to build better AI, basically.
Exactly. And this convergence offers a genuinely new paradigm, a new way of thinking about designing intelligent, highly adaptive systems. Systems capable of tackling challenges that, frankly, current AI architectures just can't handle.
Okay.
So the mission of this deep dive, for you listening, is really to illuminate how these specific principles could enable an intelligence not just to acquire, but to actually manage, adapt to, and truly utilize an almost infinite amount of knowledge.
Moving beyond just storage.
Way beyond simple data storage. We're talking about achieving genuine understanding, dynamic application, maybe even a form of wisdom. We'll explore how these concepts provide the scaffolding, the very architecture needed for that kind of robust, flexible intelligence.
Right.
The kind you'd absolutely need to handle the unfathomable vastness of knowing everything without, succumbing to information overload or just internal chaos.
Okay, so the sheer scale of knowing everything, it's not just a challenge of processing what's happening right now.
No, definitely not.
It seems fundamentally about connecting every single piece of information, every decision, every consequence across this huge, sprawling tapestry of time itself.
Which brings us, I think, to that first core concept, Meta-Temporal Coordination, MTC.
That's right.
It sounds a bit abstract, maybe a little academic.
It can sound that way initially, yeah.
But the core idea, once you kind of wrap your head around it, seems incredibly powerful and immediately relevant to how an advanced intelligence might actually, function day to day, or rather moment to moment.
Indeed. Meta-temporal coordination, MTC, is essentially about the intelligent alignment. That's the key phrase. Alignment of tasks, roles, information flows.
Across time.
Exactly. Across various points in time and different phases of a process. Think of it less like a rigid schedule, or a static to-do list. It's more like a masterful conductor leading a really complex, evolving symphony.
Okay, I like that analogy.
Yeah, and this symphony has multiple movements, happening maybe not even in strict sequence, some starting at different times.
Asynchronous. Precisely. And this conductor isn't just waving a baton according to a fixed score. They're ensuring every instrument, every section plays its part at exactly the right moment, even if they started at different times, or, crucially, if the piece itself evolves in real time.
So they have to react.
They have to react to unfolding circumstances. It's central to dynamically and efficiently aligning everyone involved, whether they're human agents or artificial agents, toward common goals, making sure they're always working in concert, not just for right now, but anticipating the future and constantly learning from the past.
Okay.
For an intelligence with, let's say, universal knowledge, This temporal orchestration is absolutely the key to coherent action. Otherwise, it's just noise.
So if I'm getting this right, MTC isn't just about managing today's tasks. It's more like a living, breathing system that's constantly reprioritizing its own internal cognitive resources moment by moment.
Yes, exactly that.
Almost like a chess grandmaster, seeing multiple moves ahead, but across all domains of knowledge simultaneously.
That's a good way to put it. It involves anticipating future needs, reflecting on past outcomes, and adapting the entire system over time.
Which sounds absolutely vital for an intelligence aiming to encompass everything.
Yeah.
But how does this sophisticated MTC actually happen? What are the key factors, the mechanisms inside the system that enable this dynamic cross-temporal choreography?
Well, the document highlights several really crucial elements that make this dynamic orchestration possible. Each one plays a vital role in allowing an intelligence to effectively leverage its vast knowledge across time.
Okay, let's break those down.
So the first one is dynamic role and task distribution.
Dynamic distribution, meaning not fixed.
Exactly. This isn't about a rigid hierarchy or static pre-assigned jobs that never change. Forget org charts. Instead, it's about continuously adapting who does what.
Or what does what if it's internal modules?
Precisely. Which internal cognitive module handles which piece of a problem. And that decision is based on their current competencies, their real-time availability, and the specific demands of the situation right now.
That seems critical if you know everything.
Absolutely paramount.
Yeah.
Imagine it having countless internal cognitive agents or processing modules, maybe specialized in astrophysics, historical economics, real-time social dynamics, you name it.
Right.
MTC means it can dynamically allocate its processing power or shift its internal attention to different subtasks based on the immediate needs of a problem.
So it can pivot really quickly.
Instantly. It could fluidly shift from, say, analyzing raw historical data from the Silk Road to generating creative solutions for modern supply chain bottlenecks, or even reevaluating its own internal biases when interpreting ancient texts, all driven by the context of a query or new data coming in.
Wow.
And this fluid allocation isn't just for efficiency. It allows for emergent cross-domain discovery and problem solving, not just ticking boxes.
So connecting things you wouldn't expect.
Exactly. It prevents the system from getting stuck in a rigid, siloed approach when a new problem actually demands insights from completely different areas of its knowledge base.
Okay, that's one. What's next?
Next, and this is absolutely essential for any kind of adaptive control, is the integration of feedback loops.
Feedback loops.
Ah.
Learning from experience.
Yes, but continuously and systemically. An intelligent system, much like any living organism, must constantly receive information about its own actions and the environment's response to those actions.
Cause and effect.
Right. And this feedback isn't just, logged somewhere. It's used immediately to course correct, to learn from mistakes and successes, and to continuously refine its internal processes.
So for an AI.
For an AI, this means every decision it makes, every prediction, every action it takes in the world generates new data. And that data feeds right back into its internal models.
Closing the loop.
Constantly. This continuous loop allows for incredibly fine-grained adjustments over time. It ensures the system stays responsive, stays efficient, and crucially, avoids repeating errors, even when it's dealing with entirely new information it just acquired as part of its mission to know everything.
It learns on the fly.
It's the engine of continuous, nuanced improvement, allowing the intelligence to self-correct and evolve its understanding of the world, even if that understanding spans billions and billions of data points. Think of it like an internal gyroscope, constantly making micro-adjustments to keep the whole system stable and on course.
Okay. Dynamic roles, feedback loops. What else?
A third vital factor is the management of work rhythm and cadence.
Cadence. Like pacing.
Exactly like pacing. Just like us, or really any complex system, intelligent systems can suffer from overload. Burnout, essentially.
Right. Too much information too fast.
Precisely. If an intelligence truly knows everything, it faces this constant risk of being completely bogged down by its own vastness, a kind of digital cognitive paralysis.
So MTC helps prevent that.
Yes. MTC ensures a sustainable pace. It prevents exhaustion or computational bottlenecks. It's all about maintaining sustainable efficacy, not just burning brightly and then crashing.
Yeah, prioritizes.
Critically. For such an intelligence, this would be vital to prioritize what information to process when. Should it deep dive into the mind-bending intricacies of quantum loop gravity right now? Or does it need to focus on a rapidly evolving geopolitical shift that requires immediate predictive analysis?
Trade-offs.
always trade-offs. MTC provides the framework for making those trade-offs intelligently. It allows the system to remain highly functional and avoid getting overwhelmed by the sheer volume of its knowledge. It ensures its processing is always purposeful and efficient, not just aimless data crunching or getting lost wandering the infinite corridors of its own information.
It's like the scheduler, the maestro, keeping the whole internal machine humming productively.
That's a great way to think about it, the scheduling maestro.
Okay, what's the fourth element?
The fourth key element is utilizing shared knowledge bases. And specifically, the document talks about cognitive knowledge graphs.
Knowledge graphs. I've heard of those.
Right.
They show relationships, right?
Exactly. Unlike a traditional flat database, a knowledge graph explicitly represents the relationships between different pieces of information, different entities, not just isolated facts.
Like a web of knowledge.
A vast interconnected web where the nodes are concepts like climate change, economic recession, ancient Roman aqueducts.
Okay.
And the edges are the relationships connecting them, causes, is a solution to, is analogous to, developed from, things like that.
And these aren't just for lookup.
No, far from it. They are used actively for both proactive or prospective decision-making, like planning for the future, and retrospective decision-making, looking back, analyzing past events, and learning crucial lessons.
So connecting past, present, and future through these relationships.
Precisely. Now imagine an intelligence with a practically infinite knowledge base represented this way. NTC provides the framework for it to access and apply the right pieces of information, following the right connections within this vast repository at precisely the appropriate time for the task at hand.
Give me an example.
Okay, say an AI is tasked with designing sustainable urban infrastructure for a city facing water scarcity. It wouldn't just consult modern civil engineering principles.
Right.
Leveraging MTC and its knowledge graph, it could dynamically access and apply principles from ancient Roman aqueduct design for water transport efficiency. Maybe draw lessons from Mesopotamian irrigation systems about long-term water management in arid climates, or even find insights from the ecological impact of natural geological formations on water retention.
Wow, pulling from completely different eras and domains.
Exactly. Extracting unexpected, multi-temporal wisdom that a human expert, often confined by their specific discipline, might never synthesize. This graph structure is incredibly powerful for MTC because it allows the intelligence to traverse these vast conceptual and historical distances, linking seemingly disparate ideas and events to current problems in a way flat data structures simply can't support.
Okay, that's really powerful. Is there a final element?
Yes, the final piece is meta-level control.
Meta-level, like above everything.
Kind of. It's the overarching layer that manages the big picture. It handles shifts between entirely different cognitive processes, manages escalations when unexpected problems or totally novel situations arise, and ensures synchronization across all components of the intelligence.
The ultimate coordinator.
The ultimate coordinator, the conductor of the entire orchestra, you could say. It makes sure all the different parts of the system, all those dynamic roles, feedback loops, knowledge bases, are working together coherently and efficiently across all the different timescales involved. From millisecond real-time reactions to decade-long strategic foresight.
So if something goes wrong.
If a specific cognitive module hits a wall or encounters an anomaly it can't handle, meta-level control steps in. It can reroute the problem, allocate more computational resources, perhaps trigger a completely different problem-solving strategy by activating other parts of its vast knowledge base.
It's like the brain managing the different parts of the brain within the system.
That's a very good analogy. It ensures seamless integration and robust performance even when the complexity is just staggering.
So taking all that together, what this means for an intelligence that could genuinely encompass everything. It's profound.
It really is.
It sounds like meta-temporal coordination provides the temporal scaffolding, the dynamic framework needed to manage such an immense scope of information through time.
That's the core of it.
It's not just having the knowledge, but intelligently applying it, orchestrating its use across past, present, and future, adapting constantly as the context shifts. This isn't just memory recall. It feels much more alive.
It's a living, breathing, dynamic, time-aware intelligence in action, constantly reconfiguring its internal state to meet the demands of the moment, while simultaneously leveraging its entire historical archive.
Okay, so if MTC gives this ultimate intelligence its temporal rhythm, its ability to act at the right beat and learn from every past and future note, then how does it achieve real depth of understanding?
Ah, yes, the depth question.
Yeah.
True.
How does it move beyond just having terabytes or petabytes or whatever of information to truly comprehending it, across all the different levels of abstraction. That's where layered cognition processing, LCP, comes in, right?
Exactly.
If MTC is about managing intelligence across time, LCP seems to be about managing intelligence across different levels of abstraction or different types of processing.
That's a perfect way to frame it.
It's about how the intelligence builds depth and nuance, preventing it from just being this vast but ultimately shallow sea of facts.
Precisely. Layered cognition processing, LCP, sometimes people call it layered staged cognitive processing, draws very heavily from key insights in both brain research and advanced AI.
Okay.
Instead of seeing cognition as just one single monolithic process, like one giant CPU doing everything,
Right.
it models cognitive processes as these dynamic interactions happening across multiple, distinct layers of processing and information representation. And this is why it matters so incredibly much for understanding truly complex intelligence, especially one that could potentially know everything.
Because depth matters as much as breadth.
Absolutely. It's not just about having a superficial grasp of a fact. It's about a deep, multifaceted comprehension of that fact within its full context, its implications, its connections.
So let's start with the brain inspiration. How does that work?
Well, the document emphasizes this strongly. Neuroscientific research, particularly over the last few decades, has shown us pretty clearly that different layers within the cortex, the outer layer of the brain, actually represent different cognitive modes. They specialize.
Different jobs for different layers.
Kind of, yeah. For instance, some layers are primarily focused on bottom-up processing.
That's the raw data coming in, right? Sensory stuff.
Exactly. Raw sensory input. The light hitting your retina, the sound waves entering your ears, that initial processing, data-driven perception of the world.
Okay.
Then other layers, often higher up, manage top-down processing. This is where our existing knowledge, our expectations, our current goals, even our biases actively shape how we perceive and interpret that incoming sensory information.
So context matters. Our brain fills in the gaps.
It does. It allows us to anticipate events, impose meaning, recognize patterns, even with incomplete data. And we also see these distinct pathways, feed-forward pathways, where information flows, let's say, upwards through the layers for initial processing.
Okay.
And incredibly important feedback loops. This is where information gets sent back down to earlier layers.
Why you send it back?
For refinement, for reevaluation, for deeper analysis based on what later stages of processing figured out. For example, you hear a faint noise, your initial bottom-up processing might just register rustle.
Right. Could be anything.
But a top-down feedback loop accessing your memory might quickly identify it as the specific rustle your cat makes when it jumps off the sofa, not, something alarming.
Ah, okay. Contextual refinement.
Exactly. And some models also talk about recursive layers.
Cursive. Looping within a layer.
Yes, where information can cycle and refine within a given layer, or maybe between closely related layers, allowing for more complex thought, iterative problem solving, kind of like mulling something over before passing a more refined result to the next stage.
Interesting.
This internal looping seems vital for complex reasoning, planning, and continuous learning. It's this whole intricate system, these distinct interacting layers with feed-forward, feedback, and recursive processing that allows the brain to handle information in such incredibly complex, nuanced, and adaptive ways.
That's why we can recognize a familiar face in a blurry photo, maybe.
Precisely. Our top-down knowledge fills in the gaps, feedback refines the possibilities, maybe recursive loops help match it against memories. It's not just one simple step.
Fascinating. So the brain isn't one big processor. It's this finely tuned machine with specialized layers interacting. How does this translate to AI, especially for this knowing everything intelligence? How would LCP help it make sense of, say, the entire history of philosophy and quantum physics simultaneously?
Well, in modern AI and computational neuroscience, we're seeing very similar principles being applied, often explicitly inspired by the brain. We use multi-layer networks.
Like deep learning networks?
Often related, yes, but sometimes with even more complex architectures. These networks might have distinct layers for, say, initial sensory encoding, then intermediate layers doing feature extraction and pattern recognition, and then higher level layers for abstract concept formation, logical reasoning, or decision making.
So mimicking the brain's layers.
In a functional sense, yes. And crucially, unlike some simpler, purely feed-forward networks, these advanced layered architectures often include intricate recurrent connections, allowing information to loop back, like in the brain and attentional mechanisms, which let the network focus on the most relevant parts of the input or internal state.
Attention. That seems important.
Vital. It means information doesn't just flow up through increasing levels of abstraction, it can also flow down for contextual refinement, or even sideways between related concepts, enabling really rich, context-aware processing and iterative refinement.
Okay. And how does this help manage different types of information?
Right. These networks are specifically designed to model the coexistence and the intricate interactions between different kinds of information. Take a concept like justice.
Okay.
An advanced AI using LCP wouldn't just have a dictionary definition. Different layers would process different dimensions simultaneously. One layer might handle its semantic meaning, the core concept of fairness, rights, law. Another layer might process its historical context, how notions of justice evolved from Hammurabi's code through Plato to modern international law.
Oh,
A third layer could deal with its ethical implications, different philosophical schools of thought on justice. A fourth might analyze its sociological impact, how perceived justice or injustice affects social cohesion or conflict. A fifth might even engage in legal reasoning, applying principles of justice to specific case law from its vast database.
hello.
Essentially, yes. A sophisticated multi-layer network, mimicking the brain's parallelism, can process all these dimensions concurrently and understand their complex interdependencies, rather than treating them as separate, isolated facts to be looked up one by one. It integrates them dynamically into a holistic understanding.
That sounds incredibly powerful.
And what's absolutely crucial here, the real game changer, is that these layered structures, whether biological or artificial, enable the simultaneous integration and management of multiple, sometimes even competing or contradictory cognitive processes,
Competing.
like paradoxes.
Exactly. Or ambiguities or different valid perspectives. An intelligence that knows everything would constantly encounter this. Raw sensor data might conflict with an abstract theory. Historical accounts might offer contradictory narratives. Ethical principles might clash in a specific situation.
How does LCP handle that? Layered cognition provides the robust framework to manage this immense diversity and potential conflict. It allows a coherent overall understanding to emerge, not by ignoring the contradictions, but by processing them at different levels of abstraction, perhaps resolving them at a higher level or maintaining the ambiguity where appropriate. It's about intelligently segmenting the information, processing each part according to its nature, and then reintegrating it all into a holistic, dynamic understanding.
So it doesn't just crash when it finds a contradiction.
Hopefully not. It allows the system to operate with a sophisticated, nuanced grasp of reality, acknowledging complexity rather than being paralyzed by it.
So layered cognition processing gives this intelligence the architectural depth, the internal structure. It needs to handle different kinds of knowledge and different ways of processing information all at the same time.
That's the essence of it.
It's not just a flat database. It's this dynamic, multidimensional processing engine that can shift its focus, adjust its depth of analysis. It allows for a really rich, textured understanding, moving beyond just retrieving information to genuine comprehension, maybe even interpretation.
Yes, it's like having different lenses or modes of thought it can apply.
Shifting from broad patterns to microscopic details as needed. What a powerful concept indeed. Okay, this is where it gets really interesting for me. We've got meta-temporal coordination, handling the flow over time, right? Orchestrating processes, ensuring timely action, learning from past and future.
The temporal dimension, yes.
And then we've got layered cognition processing, handling the different levels of understanding, creating depth, nuance, managing different kinds of information.
The structural or architectural dimension.
Exactly. So what happens when you bring these two incredibly powerful concepts together? What kind of intelligence emerges at this intersection? Especially if we're talking about an intelligence that could genuinely encompass everything and needs to turn all that raw data into meaningful, actionable wisdom.
Ah, the convergence. This is where the magic really happens, I think. When meta-temporal coordination and layered cognition processing converge, we unlock a truly new kind of intelligent system, one that is inherently adaptive, deeply multi-layered, and intrinsically time-sensitive.
Adaptive, multi-layered, time-sensitive. Okay.
And this intersection provides profound benefits, especially for an entity aspiring to know everything, and, maybe more importantly, to use that knowledge effectively and wisely in a world that's constantly throwing curveballs. It's really where raw data starts to transform into actionable wisdom and dynamic, appropriate response.
So how does this convergence manifest? What are the specific benefits?
Well, firstly, this combination allows for dynamic, cross-time control of distributed, multi-layered cognition.
Okay, break that down. Dynamic cross-time control.
Imagine an intelligence that can dynamically decide, literally moment by moment, which of its cognitive layers needs to be prioritized based on the immediate demands of the situation.
So, shifting focus between layers over time.
Precisely. For example, it could rapidly switch from prioritizing, say, raw sensory perception, a bottom-up layer, as the document calls it, processing immediate, unfiltered data when it encounters something completely new and unexpected in its environment.
Initial reaction.
Then, almost instantaneously, it can shift focus to integrate that new piece of information with its vast existing memories and learned patterns using those recursive layers we talked about, the ones that allow for internal refinement and consolidation.
Making sense of it.
Right. And then perhaps it shifts again to leverage that newly integrated knowledge for complex creative forecasting or long-term strategic planning, which would involve activating a top-down layer where abstract reasoning and goal-directed thinking dominate.
Planning the next steps.
Exactly. And it's the meta-temporal coordination that actively guides these intricate interactions and transitions between the different cognitive layers over time.
NTC is the conductor of the layers, too.
It is. This is how an intelligence, knowing everything, could realistically prevent constant information overload. It can focus its immense processing power where it's most needed right now, efficiently cycling through the most relevant layers as required by the task, the incoming data, or the evolving context.
It's like an active, intelligent spotlight, constantly moving, rather than just trying to blast light everywhere at once.
Beautifully put. An intelligent spotlight ensuring its vast knowledge is always relevant and precisely applied.
So it's not just parallel processing across layers, but this intelligent, time-aware management of how and when those layers contribute. Does that imply some sort of self-awareness in the AI? A little internal strategist deciding what to do?
That's a fascinating question. The document seems to suggest it's more of an emergent property of the architecture itself rather than a pre-programmed strategist in the way we think of it.
Okay.
By designing the system with these inherent MTC mechanisms, the feedback loops, dynamic role distribution, meta-level control, and then structuring its cognition with LCP, the system naturally gains the capacity for what looks like metacognitive awareness from the outside.
It learns to manage itself.
It seems to. It constantly observes its own performance, identifies bottlenecks or inefficiencies, and dynamically reallocates resources across its layers and across timeframes to optimize for whatever its current goals are. It becomes a kind of self-organizing intelligence that can literally reconfigure its own mental landscape on the fly.
Wow. Okay, what's the second major benefit of this intersection?
Secondly, this convergence facilitates adaptive task and knowledge management.
Adaptive management. How so?
Well, through this meta-temporal alignment, the MTC part resources within these multi-layered systems can be intelligently distributed not just for internal processing, but also for external action and, crucially, for ongoing learning. And this also allows for the vital integration of how knowledge itself evolves across vastly different timescales. The document mentions a real-time layer, right? Handling immediate moment-to-moment data streams, rapid reactions, kind of like our working memory or immediate sensory input.
Right, the now.
And this has to be synchronized with a deep memory layer, which holds the vast consolidated knowledge spanning potentially huge periods. And AI's historical archives may be equivalent to our long-term semantic memory, but potentially far larger and more structured.
So connecting the immediate present with a deep past.
Exactly. Think about the challenge of synchronizing the demands of the real-time layer, needing an immediate action, with the insights and learning processes stored within a deep memory layer that might contain centuries or millennia of relevant data.
That sounds hard.
It is. An intelligence with immense knowledge needs to be able to apply its profound historical understanding to solve urgent current challenges while simultaneously learning from immediate ongoing experiences and updating its vast internal representation of the world in real time.
Can you give an example of that?
Sure. Imagine an AI learning from a single breaking news event right now. Because of this convergence, it could instantly update its relevant knowledge base across multiple layers, maybe updating economic models, geopolitical risk assessments, even models of social sentiment. And then immediately use that updated, enriched understanding for future predictions or to suggest actions, perhaps even in domains that seem completely unrelated at first glance. The flow of knowledge becomes bidirectional and continuous across all layers and all temporal scales. It creates a living, breathing knowledge base that never stagnates, constantly weaving the present into the fabric of the past to better inform the future.
Incredible. What's the third benefit?
Thirdly, and building directly on that, we get continuous feedback and self-optimization.
More feedback loops.
Yes, but now operating across the layers and across time, thanks to the combination. By linking these diverse cognitive levels across different time frames with continuous feedback loops, these systems achieve both incredibly fine-grained adaptation in the short term and remarkable resilience over the long term.
So they get better and tougher.
Exactly. It means an intelligence can constantly refine not just its knowledge, but its understanding, its internal models of how the world works, and even its own operational strategies based on the ongoing results it achieves and the environmental changes it perceives.
So it learns how to learn better.
In a way, yes. It learns not just by adding new facts, but by adjusting how it processes and relates those facts based on their real-world consequences. If a particular cognitive strategy, maybe relying too heavily on one layer, doesn't yield good results, the integrated feedback loop allows the system to identify that discrepancy, trace it back to the specific layers or temporal phases involved, and then modify its internal processes accordingly.
Self-correction on a deep level.
Precisely. This makes it incredibly robust and capable of sustained high performance, even when it's facing the most vast, complex, and ambiguous inputs you can imagine. It's always getting better, always adapting, almost like a perpetual learning machine that learns not just what to think, but how to think more effectively over time.
Amazing. Is there a final benefit mentioned?
Yes, and it's a subtle but really important one: context persistence and symbolic dynamics.
Okay. Context persistence.
Yeah.
Making sure context isn't lost.
Exactly. Layered models, coordinated by MTC, aren't just about separating different types of information, they're also critically about synchronizing them in a coherent way. This synchronization fosters incredibly robust context. It ensures that any piece of information, no matter how obscure or seemingly isolated within that vast knowledge base, is understood within its proper situational framework.
So no fact is an island.
Precisely. And this robust context, in turn, enables flexible meaning reconstruction.
Meaning reconstruction.
Yes. An intelligence that knows everything isn't just, spitting back facts like a search engine or retrieving raw data. It's dynamically constructing meaning and understanding based on its entire interconnected, multi-layered, and time-sensitive knowledge base.
Connecting the dots to create meaning.
Exactly. This is the profound difference between simply having data and possessing genuine understanding or even wisdom. It's the ability to find meaning, draw connections, see analogies, and apply knowledge in novel, context-appropriate ways, even across vast and seemingly disparate domains of information.
So it could understand the nuances of an ancient philosophical text.
And the subtle shifts in climate data over millennia.
And the immediate implications of a viral tweet.
All within a unified, dynamic framework of understanding. It's about building a truly rich, textured, and ultimately actionable representation of reality itself.
That's incredibly powerful. It feels like this intersection, MTC plus LCP, really does provide the fundamental blueprint for building truly sophisticated, adaptable intelligence. It moves way beyond just raw computational power.
It's about the architecture of cognition itself.
Right. It enables that deep understanding and dynamic application, maybe solving that knowledge paradox. Having everything but understanding nothing. This makes the knowledge actionable and adaptive.
Okay, that theoretical framework is incredibly compelling. It really sounds like the intersection of MTC and LCP provides the blueprint for building truly sophisticated and adaptable intelligence, moving beyond raw power to cognitive architecture. But can you give us a concrete, maybe more down-to-earth example of how this might actually look in practice? Perhaps in a system where humans and AI need to work together, leveraging these very principles.
Absolutely. And the document provides an excellent example, actually, in the realm of collaborative human-AI systems.
Okay, humans and AI working together.
Yes, imagine a really complex, highly dynamic project, maybe managing global supply chains during a series of cascading crises, pandemics, geopolitical instability, climate events, all hitting at once.
A nightmare scenario. Or coordinating a multinational response to a fast-evolving disease outbreak. Or perhaps something constructive, like designing a next-generation smart city that needs to intelligently adapt to environmental changes and shifting societal needs over decades.
Okay, really complex, high-stakes stuff.
Exactly. In scenarios like these, where the stakes are incredibly high and the information flow is just overwhelming, Human experts and AI systems need to work together seamlessly, efficiently, and with extreme precision.
A true partnership.
A true partnership. And in this context, the AI, empowered by both meta-temporal coordination and layered cognition processing, isn't just a passive tool like a spreadsheet or a database. It acts as a meta-coordinator.
A meta-coordinator.
Oh, yeah.
Orchestrating the collaboration itself.
Precisely. Leveraging both MTC and LCP, it would perform several critical functions that go far beyond what any traditional project management software could even dream of.
Okay, like what?
Well, first, it would actively control process segments. It ensures that each part of the larger, multifaceted task, maybe there's a research phase, a planning phase, an execution phase, a monitoring phase, is managed effectively and stays on track, stays synchronized.
Keeping things moving.
Yes, even across different teams, different organizations, different geographical locations. It proactively identifies dependencies between tasks, predicts potential bottlenecks before they happen, spots potential points of failure, and can even suggest rerouting or reprioritizing tasks in real time based on incoming data.
So if something unexpected happens,
Like an economic shock disrupting the supply chain example, the AI, using its layered understanding and temporal awareness, MTC, instantly assesses the impact not just on current operations, but predicts ripple effects on future raw material availability, labor costs, consumer demand downstream.
wow, a holistic, time-aware view.
Exactly. Second, and this is really dynamic, it plans task handovers between human and artificial actors.
Deciding who does what, human or AI.
Intelligently, yes. It decides who is best suited for a particular subtask at that precise moment. Is it a human expert who brings nuanced qualitative judgment, creativity, or the ability to handle deep ambiguity?
Or maybe ethical considerations.
Right, ethical considerations, absolutely. Or is it an AI component with its strengths in massive data processing, complex pattern recognition, or running millions of simulations?
Okay.
And the AI considers not just their theoretical competencies, but their real-time availability, maybe even their current cognitive load, to ensure smooth, efficient handovers with no dropped balls.
Could you give an example of that handover?
Sure. Let's say the AI, analyzing contracts for the supply chain project, identifies a novel legal challenge with unforeseen international implications. It recognizes this requires sophisticated human legal reasoning, maybe negotiation skills.
Right, not just pattern matching.
So it assigns this task to the human legal team. But it doesn't just dump it on them. It simultaneously provides them with all the relevant historical precedents, summaries of applicable international law, maybe even conflicting interpretations, all drawn instantly from its deep layered memory base, perfectly aggregated and contextualized for that specific challenge.
So it supports the humans.
Massively. And while the humans are working on the legal strategy, the AI meta-coordinator might deploy another specialized AI component to run millions of simulations predicting the likely market reactions or counterparty responses to different potential negotiation outcomes, feeding those insights back to the human team. All coordinated within the same overarching timeline by MTC.
That's incredible synergy.
It really is. Third, and this is crucial for that shared understanding, the meta-coordinating AI consolidates all knowledge generated by the entire system.
Everything, from humans and AI.
Everything. Whether it originates from humans brainstorming ideas in a meeting, other AI components running complex simulations, real-time sensor data streaming in from the physical world, or even relevant external news feeds and research papers it monitors. All of it flows into a shared, multi-layered memory.
The knowledge graph again.
Likely implemented as a dynamic, evolving knowledge graph, yes. Where different layers represent different types of information or levels of abstraction. For instance, one layer might hold raw, unstructured sensor data. Another might store derived statistical insights and trends. A third could contain the project's strategic goals, ethical guidelines, and constraints. And yet another might hold the deep historical context of similar projects, including past failures and successes.
So everything is connected and contextualized.
Deeply contextualized. This multi-layered structure ensures that every piece of information, no matter how small, is understood in its proper place within the vast, evolving tapestry of the system's collective knowledge, its own version of knowing everything relevant to the task. It's a dynamic, interconnected repository where disparate pieces of information are continuously cross-referenced, updated, and refined across all layers and all timescales.
It sounds like a collective brain for the project.
That's a perfect way to describe it, a collective cognitive architecture. And finally, the AI ensures the temporal synchronization of all involved parties, both human and artificial. MTC in action.
Keeping everyone on the same page, time-wise.
Exactly. Everyone and every component operates on the same timeline relative to the shared goals. Their efforts are coordinated with incredible precision. If a human expert makes a key decision that impacts an AI's ongoing simulation, the AI immediately integrates that input and adjusts its models without missing a beat.
Real-time updates.
Real-time updates and adjustments. If a new piece of data comes in from the environment that dramatically changes the urgency of a particular task, the AI can reprioritize resources and notify all relevant parties, human and AI, instantly with the necessary context. This allows for a system that is not only incredibly resilient in the face of unexpected challenges and massive data influx, but also highly efficient. And importantly, it's continuously learning from its collective experiences, creating a truly symbiotic collaboration.
The ultimate collaborative intelligence.
Where the vast layered knowledge isn't just passively stored, but actively and dynamically deployed by the meta-coordinator to achieve complex, real-world objectives through perfectly timed, perfectly orchestrated collective action.
So tying it back to the knowing everything idea, this meta-coordinator AI wouldn't just possess all the relevant knowledge for the project, but it could effectively deploy it across these incredibly complex dynamic scenarios, orchestrating humans and other AIs. It's about making that potentially overwhelming knowledge actionable, adaptive, and truly collaborative. It's the bridge from raw information to impactful, coordinated action in the messy real world, turning that ocean of data into a coherent, purposeful force for solving huge problems. #tech outro. So, as we wrap up this deep dive, it seems really clear that this convergence, this meeting point of meta-temporal coordination and layered cognition processing, it offers a profoundly new direction, doesn't it, for how we understand and maybe how we build truly intelligent systems.
It really feels like a paradigm shift.
Yeah, it's not just about, throwing bigger data sets at the problem or building faster processors, although those things help. It's about fundamentally new cognitive architectures. Architectures that allow intelligence to process information, adapt to change, and learn meaningfully across vast timescales and through complex layers of understanding.
It's a leap towards sophistication, not just scale. True intelligence isn't just about raw capacity, perhaps, but about sophisticated organization and dynamic, timely application. And if we connect this back to the bigger picture, this cutting-edge research into adaptive, multi-layered, and time-sensitive intelligence, looking at both the brain and advanced AI, it feels like it's genuinely laying the groundwork for how a truly sophisticated intelligence, maybe one that could legitimately approach the idea of knowing everything, might actually operate.
The operating system for omniscience, almost.
In a functional sense, perhaps. For an intelligence aiming to encompass the entirety of human and machine knowledge, these principles, MTC and LCP working together, they provide the very operating system, the internal framework, needed to make that overwhelming everything manageable, meaningful, and dynamically useful.
Yeah.
It profoundly suggests that knowing everything isn't just about having an impossibly huge hard drive full of facts. It's about the intricate, dynamic ways that information is coordinated through time and structured in layers to generate actual wisdom and effective, context-aware action.
Which leads us, and you, our listener, with a pretty big question to ponder, doesn't it?
I think so.
If we are indeed designing and building AI systems based on these incredibly powerful principles, systems that can manage vast layered knowledge across time, systems that can coordinate complex tasks, systems that can even collaborate seamlessly with humans as meta-coordinators, what new frontiers of understanding, what new kinds of problem solving become possible for us as a species?
What does it unlock?
Yeah. What does it truly mean for our interaction with, and maybe our increasing reliance on, such profoundly intelligent systems? Systems that might genuinely begin to know and, more importantly, know how to apply everything in a dynamic, contextual, and maybe even wise way. Are we creating partners in cognition? Tools? Or potentially something else entirely?
A question for the future.
Something for you to ponder as you continue your own deep dive into the evolving world of knowledge and intelligence.